Hi everyone, welcome to this session. I'm going to go through Spark against Mapreduce to have a discussion to find out finally who is the winner of this battle for big data analytics. So you know that the main challenge is processing that we have to discuss and we have to find out Spark or Mapreduce. Spark memory based, Mapreduce hard disk based. All right, let's drill it down and let's see what we need to do for this discussion. So we want to discuss about the distinction between Mapreduce and Spark, and then recognize the significance of Spark and Hadoop Mapreduce in big data analytics to see what we really need to take into consideration. So Hadoop ecosystem, right? Hadoop is an open source framework based on Java that manages the storage, right? HDFS and processing, right? Means map and reduce that will be running, using Yarn uh, engine. So as you know that Hadoop uses distributed storage and parallel processing to handle big data and analytics jobs, uh, breaking workload down into smaller workloads that can be run at the same time. So as you may know that the main reason of this ecosystem is to make sure that the map reduce jobs that will be run over, the HDFS it's going to be really easy to follow and easy to understand because writing writing code, writing algorithm using map and reduce is very difficult because imagine that you want to have a for loop, you want to have like a machine learning. I mean, you want to run algorithm, using iteration over data, or you want to write a SQL query, or you want to write if then else. All right. So the big question is how to convert this easy logical coding into the parallel mode. I mean, you need to have, key and value pairs to be able to convert, your application into the mapping and reducing phases. So since it's impossible to do, we need to come over here and go through this ecosystem. Like if you want to use SQL, we need to take SQL over Hadoop like Hive. If you want to work with NoSQL, if you want to work with machine learning, right? If you want to work with the scripting and many more, all right, and many more that you need to consider. These are the components here that help us, to avoid this key and value programming, right? Parallel programming. So except Spark and Kafka that they are for, let's say, in memory processing and the streaming processing, the rest of the component here, they are based on hard disk. Hard disk means that they are very slow, right? The problem of accessing to disk because it's very slow, right? It's also slower than memory. This is the big problem, right, with map and reduce. All right, so let's say you have terabyte of data, a petabyte of data, even more, and just consider if you want to have data into your HDFS, all right, at each iteration that you want to read your data and then process it, you need to read data from, HDFS, the first iteration, process, then write into a hard disk, and then or maybe you want to read again data, you need to go over hard disk and then read data, process data, and then you might need to write it down into the hard disk, or might be you want to read it again. So guys, it's very slow, right? It's very slow, and it's going to kill the performance of your application. And the second problem, as I mentioned, is that many problems like machine learning problem, application, or even you want to write a application or algorithm using a conditional statement or using for or while loops, or you want to have uh, nested uh, nested loops or nested conditional statement. Guys, it's super difficult to do it with map and reduce. So we have these two processing problems in Hadoop ecosystem, right? In spite of having this ecosystem that they're gonna to make these two problems basically the first one easier for us. Even with this ecosystem, still the second problem is still there, right? We still need to think how to manage the second problem. To be able to, deal with these two problems, the solution would be definitely Apache Spark. So Apache Spark is an open source distributed processing system that used for big data workload, right? So what is the advantage of Apache Spark here? Using in-memory caching, right? And optimized query execution for fast analytic queries against data of any size, right? So let's say in-memory caching, right? This is, one advantage. The second advantage is optimized query execution. All right, that we can use. And because of this memory processing, you can see that even if you have your data on hard disk, you can read your data at the first iteration, and the data is going to be on the memory, right? Or on the cache. And then you again use the data for the second iteration and so on. So this is really a big difference, right, between Apache Spark and Hadoop Mapreduce. All right, taking over hard disk and memory. All right, let's drill it down, right? Because we still need to consider, these two processing units, and to figure it out when and how to go ahead with the Spark, and when and how to go ahead with Hadoop MapReduce. So first thing we need to consider is processing speed. As we discussed, Spark is basically and generally faster than MapReduce. Why? Because of, guys, this in-memory processing, right? Because the Spark can cache data in memory. All right, will reduce the need to read from disk, right? We can avoid disk. Ease of use. So Spark is much user-friendly and much better than MapReduce, because there are many API introduced for a Spark in different programming languages, like in Java, in Scala, in Python, in R. So, but MapReduce is limited to Java, right? So of course you can write MapReduce with other programming languages. There is no any restriction on that. But usually MapReduce, is based on Java, as Hadoop engine is based on Java. So, but the programming language here is not the problem, right? The API that you can interact with the programming environment to be able to track your code, to be able to, track the performance of your code, and make even, coding much easier, right? Having less line of code and provide, a great outcomes in terms of time complexity. All right. So real-time processing. So Spark supports, the basic idea of Spark. And once a scientist in University of California, they were thinking about Apache Spark. The main reason was real-time processing, right? Through its streaming API, right? Means that there is a chance to work with real-time data, to collect data at real time, all right, and respond to the environment, respond to, to data, at very short time, all right, because we are talking about real time, means we have to process data in less than a second, millisecond, even nanosecond. How we can do that? Using memory, right? In memory processing, right? As we know, memory is faster than hard disk, but MapReduce is designed for batch processing. So as you can find out here, based on these three criteria, still Spark is a right choice. Let's continue, right, and consider more stuff. Fault tolerance. So guys, both framework provide fault tolerance, all right? So, but still we need to consider Spark is still, let's say, more efficient as compared to MapReduce, because of one reason: less disk IO input and output as compared to map and reduce. All right. In terms of ecosystem and integration, we can consider Mapreduce is a mature ecosystem, right? With various tools and libraries that you can apply, and you can manage your data with any size of data. You can track, you can troubleshoot, the component in your cluster. Let's say you have like 10 workstation, you made them as a cluster. There are lots of name node, data node. You can track of, you can track, the performance of your hardware like CPU, memory. You can take control of everything through this ecosystem. All right, using different platform. Even let me introduce like Ambari that you can, install Hadoop in a distributed mode, or if you want to use proprietary, applications and providers like Cloudera, like, you know, Cloudera if you want to use, and Databricks also, which is mostly a cloud-based service. You can see that very mature ecosystem as compared to Spark. But the Spark is going to provide seamless integration. Why? Because the ecosystem is still undergrowing. All right, and I mean, the good news for Spark is there is seamless integration with other big data tools like HBase, like Kafka, or Redis, for distributed storages, MongoDB, Elastic, Cassandra, and many more. All right, these are the big differences between uh, uh, Spark and Map and Redis. Okay, let's conclude, right? What we need to do that. So the first conclusion is Spark is faster, more user-friendly, and better suited for real-time processing, right? So real-time processing means like you want to continuously, read and process tweets, right, at real time, or you want to collect and process sensory data, right, in real time. Means you can enable like monitoring and respond to the changes in the data as they occur. All right. So, but while MapReduce is designed for batch processing, right, and has provide lots of components that you are able to handle large scale data processing. But guys, it doesn't mean that you cannot use a Spark for batch processing. You can still use a Spark for batch processing, but Map and Reduce, you cannot use MapReduce for real time real-time processing. All right. So one more thing, the second conclusion would be here that we usually discuss about scalability and stability, right? Based on these two factors, you are able to decide how to go ahead, Spark or Map and Reduce. So the good news is both are going to provide scalability and stability. All right. So how does it possible? Scalability means that processing massive amounts of data like terabyte, petabyte, yottabyte, and in this case, scalability refers to the ability to handle increasing data volume without, this is important, right? Sacrificing performance. So Hadoop, how does it provide, scalability? Split data into smaller chunks means you have to make a partition of data, distribute these partitions of data across your cluster, and scale horizontally to handle larger data set. Okay, this is how Hadoop take it over. What about a Spark? So Spark distribute workload across the nodes. All right, it means that once you get data, right? So for Spark, there is no storage like HDFS in Hadoop, right? Whenever you want to work with Spark, you can take advantage of HDFS from Hadoop, or you can read data directly. So when you read data directly, it's going to take over your data, split your data into smaller chunks. All right, you can decide how many chunks, and then Spark is going to distribute workload across the node and cache data in memory and scale horizontally to handle increasing data volume. Right, guys, this is how they want to consider this scalability. About stability, again, both can provide stability. So stability refers to the robustness and fault tolerance of the system when processing large batches of data. How Hadoop do it? So Hadoop automatically detects node failure, rerun failed task on other nodes, and ensure job completion without data loss. Perfect, right? What about the Spark? Spark provides RDD, which is a data structure in Spark that we will discuss, shortly. Uh, it provides a lineage consideration to recover, lost data, recompute lost partition on other nodes, and maintain real-time processing without data loss. It means that if you want to have, lots of, operations on your data. Let's say first operation is gonna be the summation. The second operation is gonna be, you know, uh, let's say statistical analysis, and then you have another operation and another operation coming from this. And if for any reason, if there is data that you lost data, or there is any hardware failure because of this, this lineage, and this, that we call it DAG, which is a directed cyclic graph, right? Let's say if you miss, node 4 after calculation, this node 4 can recover itself by going back, through this RDD lineage and recover itself automatically. All right. So as you see that we can provide both, easily in, in Hadoop Mapreduce and Spark. So what about the cost, right? The cost is firstly infrastructure cost. So both needs, distributed computing infrastructure, but you need to consider that in terms of, uh, I mean, let's say the how you want to set up your infrastructure, you need to consider how many servers, how many storages, what about networking, the power, that these are, the main features you have to consider. But here about the storage, you can see that I'm adding storage separately because in map and reduce, let's say Hadoop map and reduce, we need hard disk, right? Hard disk is really important. But for a Spark, memory is important. It means that for storage, MapReduce is going to be, cheaper than a Spark. Let's say that if you have 10 terabyte data you want to manage, all right. If you buy, 100 terabytes, a hard disk is much cheaper than buying, let's say 1 terabyte, 1 terabyte memory. All right. So in this case, might be, uh, let's say map and reduce is going to be much better than Spark. Okay, but guys, there is no only one criteria to decide, how to go ahead, with this processing units. We have to consider more criteria that we are going to discuss and conclude at the end. Computational costs. So we said that in terms of, storage cost, HDFS for MapReduce is the right choice. But in terms of computational cost, guys, this is a trade-off, right, between computational cost and the storage cost. Storage cost goes much better. I mean, let's say goes, yeah, let's say much better for HDFS map and reduce. But for computational cost, Spark is gonna be much better, right? Because it's gonna be go over memory, and then you can take over memory for processing. Data transfer. Data transfer means that if you want to work with external sources, all right, let's say you have Cloudera, maybe you have Databricks, maybe you have external cluster, external, workstations, or maybe you want to use cloud, cloud services. You have to consider, right, how is the cost, okay, in terms of the processing and in terms of, the storage. Licensing cost. And of course, for licensing costs, you need to consider that, I mean, if you want to work with outsourcing and select external vendors, you have to consider, how much they're going to cost. So of course, if like if you know how to install Ambari, you know, you can have your own distributed uh, Hadoop ecosystem. All right. Or of course you need to, you know, you need to purchase as many as you need, you know, servers, machines, and all hardware requirements. Or maybe you want to say that you want to, you know, cut corner and go directly with existing vendors to pay, you know, the membership and get the license for either, you know, Mapreduce or Spark. So these are, you know, the consideration that we need to consider and then to be able to decide about, okay, how we can go ahead uh, for the selection. But still the question is here, who is the winner of this epic battle, Spark or Mapreduce? So after this, you know, this presentation, what do you think? Which one is the winner, right? How we have to go ahead and which one is the right choice? All right, let's discuss about the performance metrics that we have to consider to see finally go ahead with Mapreduce or with a Spark. During the presentation through the slide decks, we had this conversation. The HDD hard disk is cheaper than memory, okay? But guys, it's not necessarily enough evidence to work with map and reduce for very large data size, for petabytes, you know, yottabyte, even terabyte of data. All right, so this is gonna be, you know, very acceptable fact that the first criteria you have to consider is about, you know, the cost, you know, of the hardware, right? Hard disk, all right, and memory. So, but this is not enough really, you know, to consider. The second thing you have to consider is processing time, all right, processing time. So if you have a large data set stored in HDFS and need to perform one-time batch processing, let's say you want to have sentiment analysis, you want to have fraud detection, you want to calculate total revenue, right? MapReduce would be a good choice, all right, for one-time batch processing. But if you need to perform iterative machine learning, for instance, or you want to have, you know, a loop like for loop, while loop, or if then else, even writing, you know, the complex SQL queries, Spark would be a better choice due to its faster processing time and support for iterative algorithm. All right. So let's say that for processing time, if you have one-time batch processing, so usually, I mean, map and reduce would be a good choice. But for iterative algorithm, let's say iterative algorithm, all right. So Spark would be a better choice due to its faster processing time and support for iterative algorithm. The next criteria we have to consider is processing speed, right? For processing speed, Spark stores data in memory cache, reducing the need for disk input and output. This is very obvious, all right? So another criteria we need to consider would be complex tasks, right? Complex tasks. So MapReduce may not be the best choice for more complex tasks that require multiple iteration over data, as we discussed, you know, here at part 2. So how to conclude it? MapReduce is well suited for simple processing tasks like counting word, computing average, but it might not be the best choice for more complex tasks that require multiple iteration. So iteration, right, guys? This is the key. Iteration, iterative algorithm. So like machine learning algorithm, like, you know, optimization algorithm. All right. So if you have a iterative processing for, I mean, processing algorithm, so the framework like Apache Spark, right? Apache Flink, even Apache Apex, right? These are really great choice that they provide really better performance as compared to Mapreduce for complex tasks. All right. So another consideration here would be fault tolerance that we need to consider for Mapreduce and Spark. So let's say, for example, if fault tolerance is very critical measurement, right, in your application, then a framework like Hadoop Mapreduce might be a better choice. Why? Because it provides built-in fault tolerance mechanism. All right. So let's say that suppose you have a large data set that needs to be processed using Mapreduce. All right. The data set is divided into multiple splits, and each split is processed by a different node in the Hadoop cluster, right? This is very obvious. During the processing, one of the node fails due to the hardware or network issue. What will be happen? So guys, in this case, Hadoop Mapreduce detects the failure of the node and marks the node as unavailable. All right. The remaining nodes in the cluster continue processing. All right. And the failed input split is reassigned to another available node, right, for processing. Uh, I mean, this is the case that we can ensure that the processing of a job can still be completed successfully, even there is a failure. So as I said that since this fault tolerance um, is built-in mechanism in Hadoop, we usually go ahead with Mapreduce for fault tolerance purposes. But how does it work? How does this fault tolerance work in Spark? So Spark can provide guys a fault tolerance similar or even guys better than Hadoop Mapreduce, right? So let's say while Hadoop MapReduce has built-in fault tolerance mechanism, Spark takes a different approach to handle failure. All right. So the way to consider this fault tolerance is really different. So Spark achieves fault tolerance through a feature called, guys, RDD, right? So this RDD is resilient distributed data set, which is the masterpiece of Spark, right? That we can take it over for processing. So they are designed for these guys for default tolerance purposes. So these RDs are immutable and can also be reconstructed from the lineage of transformation applied to the original data. All right, so let's see how does it work. When a node fails in a Spark cluster, the RDDs can be reconstructed by using the lineage information, right? So that what is this lineage? As I explained, that if you have many tasks, let's say task one is to calculate revenue. After revenue, you want to have you want to calculate like the percentiles, and over this data you want to do few more processing. All right, and this direct, let's say this directed cyclic graph will be really nice information that you can track of all jobs and all tasks are going on. And whenever you miss a node or a cluster get failed, you can you can reconstruct the data by going back into these stages and find out how does it work, and it's going to take over again from the, I mean, might be from the first step or might be from the intermediate step to reconstruct the lost partition. All right, and this will ensure that the processing job can continue without interruption, all right, and without losing any data, similar to Hadoop MapReduce. So as you can see that the way they work is different. So, but I wish really to discuss about this some advantages of Spark over Hadoop MapReduce for fault tolerance purposes. All right, so as we discussed, for fault tolerance purposes, Spark, right? As we said that there is no built-in mechanism as compared to uh, map and reduce. But how Spark does go ahead fault tolerance in memory, right? In memory processing. All right, this is one advantage. The second advantage is fine, let's say fine grained lineage. All right, so why it's advantage? Because uh, this lineage can recompute only the last partition, all right, instead of recomputing the entire data set, and it will reduce the overhead of recomputation as compared to guys map and reduce. Another one that we need to consider is dynamic partitioning. So these are advantages over map and reduce. So Spark supports dynamic partitioning, which allows it uh, adaptively repartition data when failures occur. This helps in balancing the workload across available nodes and improve fault tolerance. So finally, okay, who is the winner now of this battle? Mapreduce or Spark? So with the consideration of these 5 measurements, you can find out to how to go ahead with Spark or with Mapreduce or with the combination of both. I hope you enjoy it.